Okay, so welcome to the live session. We are going to focus on the part of projectile motion. We have to focus on the part of projectile motion and understand fully what projectile motion is all about. So today we are going to look at projectile motion. So what exactly are you supposed to understand under projectile motion? What are you supposed to understand under projectile motion? So here, first of all, you need to understand what exactly projectile motion is defined like. So say the definition of projectile motion. Apart from the definition of projectile motion, you also have to understand how to derive the formulas. These formulas are categorized into three. We have the range, maximum height, and the time of flight. So, yeah, as to the part of introduction, specifically we're going to focus on these. You have to know how to define what we call the projectile motion and also how to derive the formulas. These are what we call, these are what we're going to focus on as for today. Okay, so before I go into the details of how and what are supposed to follow under projectile motion, we have to understand mostly that for something to move from one given point to the other, it undergoes a lot of things. It can experience what we call air resistance, friction force, and a lot of other things. But here, what are you supposed to be focusing on? Here we have to focus on the path taken by the object when you try to throw it. The path taken by the object when you try to throw it. So the definition for projectile, if you define what projectile is, you find that projectile motion is the path taken by the object, inside the brackets I'll say particle, which has been thrown at a given angle. So if you try to throw an object at a given angle, you understand that it is going to undergo a certain displacement. And that same object, if it has been thrown at a given angle, say it has been projected. In other ways, you can just say that is a projectile. Now, what are some of the scenarios that you are likely to be following, and what are you supposed to understand under projectile motion? So what you're going to understand is this. If you're trying to throw an object, or maybe let's say the object is moving. Remember, in dynamics, we talked about what exactly are you supposed to understand in terms of what are the some of the laws that are being applied whenever an object is moving. Same applies even here. We are going to have the same laws that are going to be applicable on this same on this same type of a formula. Okay, so for you to understand fully what projectile is all about, one, you need to know the conditions, or rather the situations, and how to describe the same situations whenever the object is moving. By the way, if we say a projectile, we mean this can be a land, a floor in short. If the object is at this as the ground, then you try to throw it at a given angle, it will take maybe this given path. If you throw this object with an initial velocity here, you find that it might take this given path. Then it will also land at that given point of projection. So if it has been raised at a given angle, or you throw it at a given angle theta, this object is going to be moving in two different scenarios. It will be moving both in y and also in x axis. It will be moving in y and x axis. What exactly does it mean? I remember under free fall, if we say free fall, if an object is falling, what exactly makes it fall down is because of its acceleration due to gravity. What we call the force of gravity is the one which makes it move downwards. So if suppose you try to drop an object from this given height, you are dropping it vertically downwards. You understand that since it is moving downwards, it is supporting gravity. That's why we are saying its acceleration due to gravity here, g, must be equal to positive 9.8 meters per second square. Now, there are cases whereby you find the object has been projected upwards, meaning that here it is opposing the gravity. So whenever it is trying to oppose the gravity, always g has to be equal to what? Negative. If an object is being thrown upwards, g must be negative. That is always. Okay, now based on this, if the object was thrown at this given point, it moved upwards and then it also returned and came to the land at which it was thrown from. Though it has landed on a different side, but still it has landed on the same floor. We call this object, it has made a symmetrical shape. It has made a complete path, like it went like this and then it also returned to its given point. Now, the time it takes for it to move from here up to somewhere there, that's what we call the time of flight. The distance it takes in the x-axis from here up to where it is going to land is what we call the horizontal range, or rather the range. The height to which it stops, or it bounces, or it takes back to its original position, you find that whenever it is moving like this, it returns. Here, the maximum point here, it shows that it is not moving for it to turn, meaning that it is stopped moving. As it is not moving at this given point, what you are going to understand is this. If it stops moving, meaning that it has reached what we call the maximum height. This is what we call a maximum height. So I'll label it as my maximum height. We do label it with letter H. So on the final point here, since it stops moving, meaning that its maximum, or maybe I would like to say the final velocity at this given point has to be equal to 0. Reason being, the object is not moving at all in that given point. Okay, so now we look at the scenarios and how are we supposed to consider the value of g. The first type of a thing is we might have the first scenario whereby this is the floor, then this becomes, or let's say this is a wall or a cliff. Then you try to throw an object, you throw it and then it lands at this given point. Since initially the object is projected upwards, here in this scenario g, or let's say acceleration, has to be equal to what? Negative g. The upward movement acceleration has to be equal to negative g. Okay, we might also have the second scenario whereby the object is going to be dropped. It is going to be thrown, like it will move like this. It will take this given path. then to land below the projection point. So since initially this object is not moving up, here acceleration has to be equal to what? Positive g. Acceleration has to be equal to positive g. Reason being, the object is not moving in y axis. It is moving with initial velocity which is pointing horizontally in the x-axis. We say v initial in the x-axis. That is the first type of, the second type of a diagram that you have to be very careful of. Okay, so there are certain cases again, you find that the object can be thrown like from the ground with initial velocity. It will take this path, then it will move and land on the same floor where it was thrown from. Even here, acceleration must also be equal to negative g. Reason being, it was initially projected upwards. It is trying to oppose the gravity. Okay, so these are the things that you have to be understanding always. Very, very important. These are the things that you have to be understanding always. Now, what are you supposed to take here for you to understand fully about the same simple diagrams? One, you need to understand what formulas are you supposed to use when it comes to what we call time of flight. Secondly, you also have to understand what formula to use when it comes to range, because we have the general range and this one as the normal range, and also maximum height, like this. Okay, now let's try to focus on one thing now, which is going to open up our minds. Let's try to focus on one thing which is going to open up our minds. Remember, if the object is moving, it is making what we call a symmetrical shape like this one. The time it takes for it to move from here up to the point where it will turn, and the time it takes for it to move from here going down has to be equal. The time it takes for it to move from here going up, it must be equal to the time it will take for it to move up to that given point. Remember, the final velocity at this given point, whenever it makes a complete shape like this one, we call it a symmetrical shape. The final velocity here must be equal to what? 0. Why? Because it almost stops moving. Yeah, meaning that it will have the initial velocity and it will automatically change here, something like that. But remember, this object has been projected at a given angle, meaning that it moves in two different sides. What are those sides? It moves in x-axis and also in y-axis. It has been projected at this given point as the initial velocity. So since it is moving in x and y-axis, meaning that it is going to have the velocity in x, v initial in x. What are you supposed to put here? We know how to resolve vectors into their components. We know that velocity is also part of a vector. So if we resolve this one into its components, we're going to have v initial in x and also v initial in y. So this is going to be v initial, because I'm trying to resolve this one, I'll say v initial cos theta, meaning that this one, which is in y-axis, it is going to have v initial, that is sine theta. So as the object is being projected, remember it always moves in two different axes. It moves both in x-axis and y-axis. Why are we saying like that? It's because it has been projected at a given angle. But what you should always understand and know is that the movement in x-axis, its velocity is constant. It is not changing. So if the velocity is constant, what are you supposed to do? That actually means that acceleration is going to be equal to 0. So as it is moving, what you should always understand is velocity in x is constant, but velocity keeps on changing in y. Why? Because this object, if it is initially projected, you know that it is moving upward and then it will come down. So the velocity at this given point can't be the same as the velocity at that given point. But in x, the velocity is going to be maintained. It will be the same. So the thing here is you need to understand how to resolve the same vector into its components, and also how to combine the same components after resolving for you to come up with a single vector, which is v initial. We understand that if we want to come up with the initial velocity, we are going to have v initial. It has to be equal to the magnitude of itself, which is going to be v initial in x square plus v initial in y square. As simple as that. So if you are able to understand, to say this is how you are supposed to be resolving the vector, or rather the projectile having the initial vector given, what you should understand now is in x-axis we are saying the velocity in x-axis is constant. So say velocity in x-axis is constant, meaning that acceleration, in this case we mean g, is 0. Take note down, take this point down, because it is very, very important, and it is the only point which is going to be helping us when it comes to calculating many questions based on projectile motion. Okay, now if we try to move a step further, we just try to focus on, in short, we try to move a step further. So what you're going to understand now is, now how do you derive the same formulas for time flight? We also have the range and also the maximum height. How do you resolve the same things? So I'll draw a projectile here. Okay, let me try to do this. Okay. Okay, so we are going to have something like this now. I'll derive all the formulas based on a projection, or rather a symmetrical shape, because I know that this can't be a symmetrical shape. Even this one is not a symmetrical shape. The combination of these two are the ones that are going to make a symmetrical shape, which is this one. The meaning of a symmetrical shape simply means the position at which the projectile was thrown from, it is the same position at which it will land, though it will be on a different side, but still that's where it has to land. Yeah, I remember from your grade 12, I think you learned about something like this, whereby someone is throwing a ball upward. They're saying you throw a ball upwards and then it returns, it comes down. Same applies even on projectile. If a ball is to take that given path and then it will return into your hands using that given path, you understand that at this given point, on the maximum point here, the final velocity must be equal to what? 0. Why? Because it is almost resting, it is not moving now at that given point. So the time it takes for it to move from here up to that side, and then and the time it will take for it to return will be the same. That's why we say the time of flight has to be the division of two different times, the time on the maximum and the time as it is moving from the maximum point. Let me try to draw it like this. Yeah, so the distance from here up somewhere there, we call it as the horizontal range, R. If the object is moving initially with this as the initial velocity, what you are going to understand is this object is going to reach on a maximum point where it is almost returning, or it is returning. So this is going to be my maximum height. The time it takes for it to move from here, move up and then return to the original position, or landing on the same part, that's what we call the time of flight. And the time it takes for it to move from here up to there, it has to be equal to the time it moves from here up somewhere there, meaning that time of flight will just be the double of these two, this time and that time. So I'll label this one to be my T1, the time for me to move from here up to the maximum point, and then the time from here up to down there, I'll say this is my T2, like that. Okay, we proceed. So what you're going to understand here is this. Definitely, if you want to know the time of flight, the range, and the like, you have to consider this object which is moving or which has been projected at this given point with the initial velocity v0. This object which has been projected at an angle theta, it is going to be moving in x and y. Remember I said in x-axis velocity, the initial velocity to be the same as the final velocity. Why? Because velocity in x doesn't change. So I'll say v initial in x has to be equal to what? After resolving, this is going to be v initial. You say cos theta. And also we are going to have the other velocity in y, v initial in y. It has to be equal to v initial sine theta, like this. But what you should always understand is what are the formulas that we are supposed to be using when calculating time of flight, the range, and also the maximum height. Remember I'm saying in the x-axis, velocity is not changing. Velocity is not changing. Meaning that this one, which is a range, it only applies to symmetrical shapes. By the way, this is a symmetrical shape. That is my symmetrical shape, something like that. A symmetrical shape means something which is formed like a half of a circle. But a quarter of a circle is not a symmetrical shape. This applies if the object is moving from here, you throw it, then it will take that given path, of which here, if it is moving from top going down, the time, the value of g, which is 9.8, has to be positive. But whenever it is initially moving like this, what you are going to understand is it must have a negative gravitational acceleration. Let's try to look at how are we supposed to be driving the same formulas that we are going to be using when it comes to calculations. We have so many formulas that applies and that we learned from our grade 12. We learned about so many formulas under kinematics. We learned about so many formulas under kinematics from grade 12. We learned about this formula, the first one, V final. Some people they say U, but here we're not using U. Say V initial. Say plus A T. We also learned about V final square equal to V initial square plus 2A S, where S is the displacement and A acceleration. Okay, we also learned about something which is also very important. We say S is equal to that is V initial T plus 1 over 2 A T square. These are the formulas that are very applicable when it comes to calculating or maybe when driving the same formulas. Remember we are saying you have this. Here G is considered to be negative. Why? Because the object initially it is moving up. Same applies if you are trying to throw an object upwards, it is opposing the gravity. That same gravity must be negative. But here, since it is dropping like this, you find that G must be equal to positive. For this one, G has to be equal to negative also. Why? Because initially the object is moving. I just forgot to make mention of one thing which is also very important. A different type of a path is this. You'll find that you're going to throw an object on this given height. Then if the object was thrown like this, it took this path and then it went beyond the original position and then it lands on the bottom. Initially, since this object is moving like this, having the initial velocity, it is not making a symmetrical shape. It only makes a symmetrical shape if you cut it at this given point. Meaning that if they ask you to say what is the maximum height for this one, the maximum height can be due to or with reference to the height of the cliff and also that given point. But if there is no specification, the maximum height here, they mean the height at which it reaches after being thrown. So this one, G, has to be equal to negative. Why? Because initially the object is moving upwards. Then after it lands beyond, you find that now it has gone beyond the point from where it was projected. The height is going to be considered as negative. Reason being, it has gone beyond now the point from which it was projected. So the time it takes for it to move from here going down can't be the same time when you are trying to consider this one. Meaning that when it comes to the issue of time of flight, you want to consider the same formula I'm going to drive for you when calculating for time of flight for this one, for this type of a graph. For this type of a diagram. Okay, so these are the formulas that you have to be using. So whenever we try to look at this first formula, where exactly can it be applicable? You are going to understand that here, if the object initially is moving upwards, we are saying acceleration, we are saying g has to be equal to negative. And then when the object is moving downwards, initially, g must be equal to what? Positive. Okay, so these are the formulas that you are going to be using in terms of driving a so-called time of flight, range, and maximum height. Very, very important. This only applies to a symmetrical shape. You can only find the distance from here up to where it lands if you are using the same formula as I'm going to drive. Meaning that for for range you are going to focus on this one. Why? Because I think you can check. Because range, the starting point here, R, you can either derive it using this or this one, depending on whatever you have. Let's try to drive some of the formulas. Specifically, I'll start from the time of flight. How are you supposed to drive the same time of flight? I'll use this one. Why am I going to use this one? It's because it is the only thing which it is going to have the maximum height and then also and the acceleration. The time, that is what we want to drive. We want to drive the time. Remember, I'm saying the time it takes for it to move from here up to that given point will be the same time it will move from here up to that given point. Meaning that first of all, I can just drive the time it takes for it to move from here up to that side. After driving that same time, I'll just add or I'll multiply it by 2 and it will give me the total time, which is a time of flight for this entire path taken by the projector. Okay, so remember I'm trying to use this one, V final, which is equal to V initial plus A T. And then we are saying this has to be my G. But since initially the object is moving upwards, meaning that this same G has to be what? It has to be negative. Then you come here on the maximum point. I'm saying the final velocity here must be equal to what? 0. And what path are you going to be considering? This thing initially it is moving upwards, or rather it has been projected towards the y-axis, meaning that for me to find the time, since it is moving upwards and then it reaches this given point which is in the y-axis, I'll use the initial velocity in y-axis, which is what? Which is that one. This is what I'm going to replace where there is initial velocity. So where there is this, you have to put the y the y velocity, the initial velocity in y. So this one is going to have the initial velocity in y, which is going to be v initial sine theta. Why? Because the object initially it is moving upwards. For it to have a 0 maximum here, we are going to consider the maximum, the initial velocity in y-axis. It will come again for the time for us to consider the velocity in x-axis. So what we are going to do, we are saying on the maximum part on top here, we are saying the velocity must be equal to 0, which is the final velocity. Meaning that this one, I'll put 0 on it. I'll say equal to v initial sine theta, I'll say plus. So since I'm saying the object initially is moving upwards, it is moving upwards, meaning that g, for this one, we are saying g must be what? Negative. Then you are going to take the same negative g and place where there is acceleration. I'll say negative g, say multiply by t. Remember, I want to come up with the time of flight. How are I supposed to calculate for the time of flight? So since here g has already been used as a negative, when calculating for time of flight, do not consider g to be negative again. Why? Because during the derivation, we already considered g to be negative. So I'll continue. We are going to have you can make this move to the other side, or you can take this one to the other side. We're going to have t equal to v initial sine theta. To make t the subject of formula, you divide throughout by what? By g. Mean that t has to be equal to v initial sine theta over g. So remember, we are saying the time it takes for it to move from here going up will be the same time it drops down. Meaning that this one we have to multiply it by 2, or you add it. You multiply by 2, reason being we are going to have t, which is going to be v initial sine theta over 2, over g. You add it with again the same time. So time of flight, which is t, has to be equal to what? You say v initial sine theta over g. I will say plus v initial sine theta over g. Then time of flight, once you derive the formula, is going to be 2 v initial sine theta over g. This is the time of flight. I'll just deal with the derivation of these two formulas and then I'm done. Okay, now what about the issue of range? If you want to go to range, which is the distance from here up to somewhere there, what are you supposed to do? Meaning that if you consider this one, if you take this one to be a range, what you're going to understand is this. Or if you take this one to be a range, what you're going to understand is this. This object, initially, it is moving it is moving upwards. But now, since I'm considering this one, or maybe that one, to say my time has to be the total time it takes for it to move from here up to that side. So in short, I'm going to use the time of flight wherever there is what? Wherever there is t. So what are we supposed to do in this case now? What are we supposed to do in this case now? Remember, I'm saying in the x-axis, velocity is constant. Acceleration has to be equal to what? 0. So if you take this one to be your formula to use when deriving what we call the range, what you should always do is you put this one to be equal to 0. So if you take this to be equal to 0, entire thing here is going to be what? The entire thing is going to be equal to 0. So I'll choose this one to calculate for what we call the range. So I'll say S. In this case, I'll take this one to be my range now. I'll say R, which is the distance in x-axis. R has to be equal to. So since we are trying to talk about the range in x, meaning that here I'll use the velocity in where? In the x-axis. What are we supposed to do? I'll write v initial cos theta. I'll say t. And then I'll add plus 1 over 2. Okay, so since acceleration is going to be equal to 0, meaning that the whole lot of this part is going to disappear, we're going to have a 0 on that same part. Okay, so now you look at this one. The total time it takes for this object to move in the x-axis, we are saying it has to be what? It has to be this one. Meaning that what you are going to do here has to be something like this. For you to understand, to say what time are we going to use, you have to use the same time, which is a time it takes, since the time to move from here up to that given part is just one and the same as the time it will take for it to move from here going down there. Meaning that where there is this, I'll just put the total time it takes for it to cover that same displacement. Then R is going to be equal to what? You say v initial cos theta. Where there is this, we're going to replace with 2 v initial sine theta over g. And then v and v can be multiplied. V and v can be multiplied. If you try to multiply, what answer are you going to get? You're going to have R, which is going to be equal to 2 v initial square. Once you multiply this and that one, then I'm going to have cos theta sine theta over g. So if you want, you can even leave it from here, but if you want, you have to maintain this one using a simple identity, which is going to be as follows. The simple identity for that one has to be R Sorry, just a bit. Okay. We made a mistake. The time we're going to use the same comma simple time because the time is the same. Sorry. So we have to remove this one, not this one, no, but you have to use a simple time. Okay, so say equal to, we're going to have v square, sorry, initial. Then since we're going to have v initial square, since we want to come up with the identity for that one, what identity are you going to come up with for this part? You understand that the simple identity for this one is going to be like this. We're going to have sine 2 theta over g, something like this. This becomes the range that we're going to be using. You can even leave it from here. So the maximum, if they say what is the maximum range for the horizontal, for the projectile, always maximum range appears at an angle of 45. They can even ask you to say, can you calculate the range? And then they also say what is the maximum range. So always maximum range appears at 45 degrees. What does it mean? This means that if you take this 45, you replace where there is theta, you are going to understand that it is going to be 90. Then v sine 90, this is just one and the same like v square over g. That's all. The last thing which I can also mention is how to drive what we call the maximum height. How to drive the maximum height. For something to have a maximum height means that it is moving in the y-axis. What are we supposed to do, or what formula are we going to use amongst the three given formulas? Here definitely we are going to use a formula which is found in the middle. I want to find this one. So since the object initially is moving upwards, meaning that this at the initial velocity, you need to consider it as the velocity in y-axis. And then at the final point, you are saying the final velocity must be equal to what? 0. So I'll say v final square equal to v initial square plus that is 2as. Remember, the object is initially projected upwards. All the formulas we're trying to derive here, you are going to be using them like the way they are. G shouldn't be taken as negative again once we derive these formulas. So since the object is initially moving upwards, what are you supposed to do? You are going to understand that this is going to be equal to 0. But here, the initial velocity must be the initial velocity in where? In y-axis, which is v initial sine theta. And then this one has to be what? Negative g. And this one is going to be the maximum height, which is h. So I'll say 0 has to be equal to, if you take this and replace there, we're going to have v initial sine theta square minus, because if you take this one on that side, you are going to have what? Minus now, say 2gh. Remember, we don't square the theta, we only square the identity which is used on the part of theta. So we're going to have 0 equal to v initial square, and I'll say sine square theta. We don't square the theta, we only square the identity which is attached to theta, minus 2gh. If you take this one to the other side, we're going to have 2gh equal to v initial square sine square theta. You divide by 2g, divide by 2g, meaning that if they ask you to say what is the maximum height, which is h, has to be equal to v square sine square over 2g. Here, if you want to calculate for maximum height, just take g as 9.8. Why? Because initially when driving this formula, we already considered g as what? As negative. Either if the object is projected like this, still the maximum height, which is going to be the distance from here up to that side, you have to take it as the formula which is written at this given point. Yeah, so this is where I'm going to end in terms of introducing this simple topic and how to derive these formulas.